All right, let's jump right into a question that sounds, well, almost too simple. You've known the answer since you could count on your fingers. But the real why behind it? That's a journey into the very heart of logic and math itself. So, why does 2 plus 2 really equal 4? Let's dig in.
We all know this one, right? It's the classic setup. Just picture it. You've got two apples in your hands. Then a friend comes over and gives you two more. The question seems pretty straightforward. How many apples do you have now? Four! Of course it's four. I mean, you can literally see them. You can count them. In the physical world, it's completely obvious. 1, 2, 3, 4. End of story, right? Well, not quite. And here's where things get really cool. How can we prove this without any apples, without any objects at all? How do we show with pure, unshakable logic that this isn't just a coincidence, but a fundamental truth? That's the real puzzle. To answer that, we've got to peel back the onion. We can't just rely on counting things we see. No, we have to go deeper and figure out what a number even is and what it truly means to add something in the first place.
So, step 1 on this journey is to define our terms. What are we actually talking about when we say 2 or 4? They're not just symbols on a screen. They are ideas, concepts, and they're all built on one very simple, logical foundation.
Everything, and I mean everything, starts right here with the number 1. You can think of it as the first building block, our basic concept of a single thing. This is our starting line for all of arithmetic.
So then, what's a 2?
Well, mathematically speaking, 2 isn't just its own separate thing. It's formally defined as the successor of 1. It's just the very next concept in line after 1, which we write down as 1 plus 1. And you can probably see the pattern here. It just keeps going. The number 3? That's simply defined as the successor of 2. It's the next logical link in the chain. We take the idea of 2 and add our basic building block, 1. And finally, we get to 4. You guessed it, it's formally defined as the successor of 3, or 3 plus 1. See? Each number is built directly on the shoulders of the one that came just before it. So here's the big takeaway. Numbers aren't just some random lists of symbols we memorized. They're an ordered, logical chain. Each number is simply the one before it plus our fundamental unit, 1. It's a totally unbreakable sequence.
Okay, so that's one piece of the puzzle down. We've defined what our numbers are. Now we have to define what we're actually doing with them. In the world of pure logic, what does that little plus sign really truly mean?
Put simply, addition is just the formal, official operation for combining quantities. So when we write down 2 plus 2, we're asking a very formal question. What is the total quantity when this group is combined with that group? Now, you can't build a formal proof without having some ground rules, some axioms that everyone just agrees are true. For addition, it turns out you only need 2 incredibly simple rules to build, well, everything. And here they are. Rule 1, super simple. Adding 0 to a number doesn't change it. Yep, makes sense. Rule 2 is the really clever one. It looks a little weird, but all it's saying is this. Adding the next number is the same thing as adding the original number, and then just taking the next number of the result. That S thing just means successor or the number that comes after. And that's it. These 2 rules are all we need. All right, this is it, the moment of truth. We've got our definitions for numbers, and we've got our rules for addition. Now we can finally put it all together and build the logical proof, step by step. So let's walk through it. We start with 2 plus 2. First, we'll swap out the second 2 with its official definition, the successor of 1, or S of 1. Now we have 2 plus S of 1. Hey, that looks exactly like our rule 2. So we apply the rule, which lets us transform it into S of 2 plus 1. Now, what's inside those parentheses? Well, we know that 2 plus 1 is just the definition of the number 3. So the whole thing becomes S of 3. And what is the successor of 3? By definition, it's 4. Boom, done. And there you have it. We didn't need to count a single thing. We just use our starting definitions and our rules, and we followed the chain of logic. The answer isn't just a fact we memorized. It's a necessary conclusion based on the very system we built. So, what does all this abstract, brainy stuff have to do with the real world? Let's bring it all the way back to those apples and see how these 2 worlds connect perfectly. When we see 2 apples, and then someone adds 2 more, our brain is actually following these exact same logical steps, just intuitively. We take our group of 2, then we add the next one to get 3, and then the next one after that to get to 4. Our brain is running a proof without us even knowing it. And really, that's the key here. This formal proof isn't some weird alien concept. It's just the super precise, crystal clear language that mathematicians came up with to describe the simple act of counting that we all do naturally. It shows that our intuition is built on something rock solid. So we've laid down this unbreakable foundation for why 2 + 2 = 4, starting from just the idea of 1. But, this is just the tip of the iceberg.
Think about it. If it takes this much careful step-by-step logic just to prove addition, what does the proof for multiplication look like? Or for exponents? It just goes to show you that underneath every simple truth we take for granted, there's this beautiful logical universe just waiting for us to explore.